Dive into 101 must-know concepts necessary for acing the General Machinist Red Seal license exam. Access comprehensive preparation materials at www.cannycollege.com to ensure you are fully prepared for success. Part 2. 5-6 Reams holes using a conventional lathe. Involves using reamers or adjustable reaming tools mounted in the lathe tailstock to enlarge and fine-tune hole dimensions, improve accuracy, and achieve desired surface finishes. 5-7 Cuts grooves using a conventional lathe. Refers to creating internal or external grooves, slots, or recesses on workpieces using grooving tools, parting tools, or form tools on the lathe machine for keyways, O-rings, or retaining rings. 5-8 Cuts threads using a conventional lathe. Involves forming internal or external threads on workpieces using thread cutting tools, taps, or dies in the lathe spindle, or cutting directly with threading tooling to create screw threads with accurate pitch, depth, and profile. 5-9 Select conventional milling machine types. The process of choosing the appropriate type of milling machine, such as vertical, horizontal, universal, or bed-type mill, based on the specific machining requirements and workpiece characteristics. 6-0 Plans milling sequence. Involves organizing and scheduling the order of milling operations, tool changes, tool paths, cut depths, and feed rates to optimize efficiency, accuracy, and surface finish in the machining process. 6-1 Sets up work-holding devices for conventional milling machines. Refers to mounting and adjusting clamps, vices, fixtures, or angle plates on the milling machine table to securely hold and position workpieces for milling operations. 6-2 Sets up tooling for conventional milling machines. Includes installing and aligning cutting tools, such as end mills, face mills, slotting cutters, or drills, in the milling machine spindle, tool holders, or tool changer to prepare for milling operations. 6-3 Set up milling accessories. Involves attaching and adjusting milling machine accessories such as rotary tables, dividing heads, indexing fixtures, or digital readouts to enhance milling capabilities and perform specialized machining operations. 6-4 Sets up the workpiece on a conventional milling machine. Involves fixturing and aligning the workpiece on the milling machine table or fixture using clamps, bolts, or vice jaws to prepare for milling processes. 6-5 Select conventional milling machine speeds and feeds. Refers to choosing optimal spindle speeds, feed rates, and cutting depths for milling operations based on workpiece material, tool diameter, geometry, and desired surface finish. 6-6 Mills surfaces using a conventional milling machine. Involves removing material from the surface of a workpiece using the face of the milling cutter to achieve flat, uniform, and smooth surfaces with specific dimensions and finishes. 6-7 Mills profiles and pockets using a conventional milling machine. Refers to cutting complex or irregular shapes, contours, or cavities on the workpiece surface using end mills or profile cutters to create pockets, slots, or intricate features. 6-8 Mills slots, grooves, and keyways using a conventional milling machine. Involves cutting straight or curved slots, grooves, or keyways on workpieces using end mills or slitting saws to create precise recesses or channels for keys or other components. 6-9 Cuts gears and splines using a conventional milling machine. Refers to machining gears, splines, or tooth profiles in workpieces using specialized gear cutters, index heads, or form tools to produce accurate gear profiles and spline shafts. 7-0 Drills holes using a conventional milling machine. Involves using drill bits, center drills, or milling cutters mounted in the spindle or tool holder of the milling machine to create holes in workpieces with specific diameters, depths, and locations. 7-1 Reams holes using a conventional milling machine. Refers to enlarging, finishing, or fine-tuning drilled holes in workpieces using reamers or adjustable reaming tools on the milling machine spindle to achieve precise hole dimensions and surface finishes. 7-2 Cuts countersinks, counterbores, chamfers, and spot faces using a conventional milling machine. Includes forming conical recesses, stepped holes, beveled edges, or flat surfaces around holes in workpieces using specialized tools or cutters in the milling machine spindle. 7-3 Performs tapping using a conventional milling machine. Involves cutting internal or external threads in workpieces by using tapping tools, taps, or tapping heads in the spindle or tool holder of the milling machine to create accurate threaded holes. 7-4 Bores holes using a conventional milling machine. Involves enlarging existing holes, creating precise internal cylindrical holes, or boring out cavities in workpieces using boring heads, bar holders, or boring tools in the milling machine spindle or tool post. 7-5 select power saw types. Involves choosing the appropriate power saw based on the specific cutting requirements such as circular saws, band saws, miter saws, jigsaws, or reciprocating saws. 7.6. Select saw blades. Refers to selecting the suitable saw blade based on the material to be cut, the type of cut required, and the size of the workpiece, such as tooth count, blade material, and diameter. 7.7. Install saw blades. Involves mounting and securing the selected saw blade in the power saw machine, following proper procedures for blade alignment, tightening, and safety measures. 7.8. Selects power saw speeds and feeds. Involves determining the appropriate cutting speeds and feed rates for the material being cut and the type of cut, ensuring optimal cutting performance, blade life, and workpiece quality. 7.9. Makes power saw adjustments. Includes setting up the power saw for specific cuts by adjusting blade depth, bevel angles, cutting direction, or fence position to achieve accurate dimensions and the desired cutting results. 8.0. Sets up the workpiece on a power saw. This involves securing and aligning the workpiece on the power saw table or fence using clamps, jigs, or fixtures to ensure safe cutting, precise measurements, and proper guidance during the cutting operation. 8.1. Saws straight and angle cuts. Refers to cutting workpieces in straight, diagonal, bevel, or mitered angles using the power saw while ensuring accuracy, consistency, and smooth edges in the cut material. 8.2. Cuts irregular shapes. Involves cutting complex, irregular, or contoured shapes in workpieces using specialized cutting techniques, jigs, templates, or guides on the power saw to achieve intricate cuts and multiple angles. 8.3. Select precision grinding machine types. Involves choosing the specific type of precision grinding machine like surface grinders, cylindrical grinders, tool and cutter grinders, or internal grinders based on the grinding operation requirements. 8.4. Plans grinding sequence. Refers to organizing the order of grinding operations, wheel selection, cutting paths, and setup adjustments to achieve accurate dimensions, surface finish, and geometric precision during the grinding process. 8.5. Set up work holding devices for precision grinding machines. Involves installing and aligning fixtures, chucks, centers, or work supports on the grinding machine table to properly secure, position, and guide the workpiece during grinding operations. 86. Mounts grinding wheel. Includes selecting the appropriate grinding wheel, installing it on the grinding machine spindle, dressing or truing the wheel if necessary, and aligning the wheel with the workpiece for precision grinding. 8.7. Set up grinding accessories. Involves attaching and configuring grinding accessories such as wheel guards, coolant systems, lighting, or wheel dressing tools to enhance the safety, efficiency, and performance of the grinding operation. 8.8. Sets up workpieces on precision grinding machines. Includes placing, aligning, and securing the workpiece on the grinding machine table or chuck using clamps, magnets, or fixtures to prepare for grinding specific surfaces, features, or profiles. 8.9. Selects precision grinding machine speeds and feeds. Involves determining the optimal grinding wheel speed, table feed rate, depth of cut, and the direction of feed for precise material removal, surface finish, and dimensional accuracy in grinding operations. 9.0. Grind flat surfaces using a surface grinder. Refers to machining flat surfaces on workpieces using a surface grinding machine, abrasives, and precision control to achieve smooth, parallel, and accurately dimensioned surfaces. 9.1. Grinds profiles. Involves grinding complex profiles, contours, or shapes on the workpiece using specialized profile grinding wheels, dressers, or templates to achieve intricate surface patterns, curves, or angles. 9.2. Grinds internal and external cylindrical and tapered surfaces. Includes using precision cylindrical grinding machines to grind internal, external, cylindrical, or tapered surfaces on workpieces with accuracy, concentricity, and geometric precision. 9.3. Grinds tools and cutters. Involves sharpening, reshaping, or restoring cutting tools, drills, milling cutters, or inserts on a tool and cutter grinder to ensure sharp edges, accurate profiles, and optimal cutting performance. 9.4. Finishes holes using a honing machine. Refers to improving hole geometry, surface finish, and dimension accuracy of drilled, reamed, or bored holes in workpieces using a honing machine with precision honing stones or diamond abrasives. 9.5. Performs basic CNC programming. Involves writing, editing, or modifying CNC, computer numerical control, programs using programming languages or software to control the movements and operations of CNC machine tools. 9.6. Review process documentation. includes reviewing written instructions, blueprints, drawings, work orders, or process sheets to understand machining requirements, specifications, tolerances, and sequencing for a machining operation. 9.7. Calculates coordinates for the toolpath. Involves determining the precise X, Y, and Z coordinates for tool movements and cutting paths based on workpiece dimensions, tooling sizes, machining strategies, and programming requirements in CNC machining. 9.8. Creates basic program. Refers to developing a CNC program using G codes, M codes, or conversational programming techniques to specify tool movements, speeds, feeds, cutting depths, or other instructions for machining operations on CNC machines. 9.9. Inputs program into control memory. Involves transferring the CNC program from a computer, USB drive, or network server to the CNC machine control unit memory for execution, ensuring the correct program version, safety checks, and verification before machining. 100. Optimizes program. Includes refining the CNC program by adjusting toolpath strategies, speeds, feeds, cutting parameters, tool changes, or additional commands to enhance machining efficiency, accuracy, quality, or tool life. 101. Select tooling and tool holders for CNC machine tools. Involves choosing suitable cutting tools, inserts, end mills, drills, or tool holders based on material, cutting requirements, machine compatibility, spindle type, and programming considerations for CNC machining. 102. Sets up tooling and tool holders for CNC machine tools. Includes installing, aligning, and securing cutting tools, inserts, or holders in the machine spindle, magazine, or automatic tool changer and validating tool offsets, lengths, and tool paths for accurate machining. 103. Sets up the workpiece on the CNC machine tool. Refers to positioning, aligning, and securing the workpiece on the machine table, jig, or fixture using clamps, vices, or magnetic holders to ensure proper orientation, stability, and accuracy during machining. 104. Establishes work datum. Involves setting reference points, workpiece origins, or part zeros on the CNC machine control system to define the starting position, axis orientation, and coordinate system for machining operations based on part features or program requirements. 105. Verifies program. Includes checking the CNC program, tool paths, feed rates, tool changes, and safety stops, performing simulation or dry runs, and visual inspection of the tool movements to confirm the correctness, integrity, and safety of the machining program. 106. Operates CNC machine tools. Involves starting, running, and controlling the CNC machine, running the specified program, monitoring tool movements, cutting processes, and machine status to ensure proper operation and part quality during machining. 107. Adjusts offsets. Refers to modifying tool offsets, work offsets, or program settings to align tool positions, tool lengths, or workpiece origins with the desired machining positions, dimensions, or part features on the CNC machine. 108. Monitors machining processes. Includes observing, measuring, and analyzing machining parameters, cutting performance, tool wear, chip formation, surface finish, and coolant flow during machining to ensure process quality and address any issues promptly. 109. Interrupts program cycle. Involves pausing, stopping, or halting the CNC program execution to address malfunctions, tool breakage, material issues, or safety concerns, ensuring operator or machine safety and preventing damage to workpieces or tools. 110. Restarts the program cycle. Refers to resuming, restarting, or reloading the CNC program after an interruption, tool change, or adjustment, ensuring that the machining operation continues from the correct program point without errors or deviations in the workpiece.